Okay, we're really making progress. At least I am. We, once again, what is our goal today? Our goal is to get better acquainted with the whole test, but specifically today, free response questions. So I've looked at the year 2018 and very fairly recent year and decided I am going to go over each one of the questions. We're up to question number 3. We did 1 and 2. Question number 3, I will read it in a moment, but is on probability. Normally considered a little bit difficult. Our first question I thought was easy, was on the linear model, just knowing how to read the output from the linear model. And the second question was on confidence intervals, which is a little more difficult, but still not too bad, not too bad. So study, study, study. All right, next question. I'm reading it, number 3 right now, and I will post the question with this video. Approximately 3.5% of all children born in a certain region are from multiple births, meaning twins, triplets, or more. Of the children born in the region who are from multiple births, 22% are left-handed. Of the children born in the region from single births, 11% are left-handed. My first response to this is, I love it when a question that we're doing for an AP question correlates to something we did in the book or something we did in class. Now remember, and I know any of you who were paying attention would say, yeah, we did. The airport, Leah, I think her name was Leah or Leah in the airport, and also the one on public and private schools and graduation rates. This question, I think, is very similar to that. At least that's what I'm thinking right now. It says, what is the probability that a randomly selected child born in the region is left-handed? Now, I'm going to say right now that this is, when you have 2 different outcomes, this is perfect stuff for a tree diagram. I'm not saying you have to do it via a tree diagram. There's probably another way. Let me see what the book didn't do it by a tree diagram, but it helps me. I mean, the book, when I say, I mean AP. But I think a tree diagram shows what's going on better. So if you look at my little tree up there, I broke it down into single births and multiple births. It gave us 3.5%. So knowing it's got to be one or the other, it's 96.5% on the single births. And then it gave you 11% for left-handed, obviously 89% right-handed. Then it gave you 22% left-handed from the multiple births, 78% right-handed. And then multiplying the 2 probabilities together, you get, I'll read them off. Coming from a single birth and being left-handed, about 10%. Coming from a single birth and being right-handed, about 85.5%, about 86%. Coming from a multiple birth and being left-handed, well under 1%. And then, well, not well under, close to 1%. And then coming from multiple births and right-handed, about almost 3%. Now you know how you got there is you multiplied the 2 together. Now, if you added them up, which I did, you should get 1.0 or 100%. Question A. I'm going to attempt to do this. No, I'm not. I was going to do this whole question, but I think it works better by breaking it up. 3A says, what is the probability that a randomly selected child born is in the region? Let me read that again. What is the probability that a randomly selected child born in the region is left-handed? This question is so much like that airport question and the luggage being there. It's not funny. It really is. So I got left-handed with single births is 0.10 0.615 plus left-handeds from multiple births 0.0077, and I get a total of left-handed at 0.11385. And that's part one, or part A of the question. And let me make sure it's right. It is. Okay. So we will shut her down and pick up with part B in a moment.